Good morning, students. We are doing lab 5, okay? And part A, Newton's second law. Remember? F equals ma, okay? And then let me introduce to you the apparatus. You did in lab, you have used air track, okay? I did not show, or I'm not going to show details. It's about an hour it took me to set up the experiment, okay? So please look at the video. Here is your air track. Here is the photogate timer. Here is the auxiliary photogate timer, okay? And today you'll see, you'll measure time to distance. Distance here is not this. It is the flag. It is a 2.5 centimeter flag. You convert that into meter, 0.025 meter, okay? So this distance divided by the time to cross this photo gate, okay? So you'll measure, times, you take the average of it if you look at your data table, okay? Let me introduce you to the apparatus we are using, okay? Air track, then length of the glider, 2.5 centimeter or 0.025 meter, okay? And procedure, please look at your procedure. And procedure 4, it said add 50 to 60 grams. No, I'm going to add 80. Okay? Each of them is 10 grams. So in one side 20 grams, other side 20 grams. You'll see why, because I'm going to take 10 grams from sliding glider to the falling. Okay, this mass, see, we're going to start falling mass. This mass hanger is already 50 grams, and then I'm going to put another 5 grams. Okay, I'll take 10 grams from the glider and I'll put it here. So if you look at your data table, right, and okay, is the, if you do that, this is 265 grams. The data table will be provided to you. Okay, so the first one, 265 is the sliding mass. 50 plus 5, 55 grams is the falling mass. Okay. Second data table, I take 10 grams from here. Okay, and I'll put it here. So 165, this becomes 265 becomes 245. Okay, and 55 becomes 65 grams. Follow? So we'll take only 4 changes. Okay, so then we'll take everything out. Okay, the sliding mass will be 115 grams and falling mass I'll be varying 205, 245, 405 and 445 grams falling mass. Okay, your data table, page 4, data table 5A1. If you look at data table, keep first 4 entries gap, then another 4 entries, 4, okay? I'll provide it to you, okay? So don't worry about the data table. Try to learn how to do the experiment, okay? Then you'll be all right. And also the Friday, you guys will be doing this lab. I'll explain more, okay? So what? Let me set up the experiment. I have 2 friends, helping me here. Normally, you need 4 people to do the experiment, but we'll try to finish it with 3 people. Okay, great. Let's watch. First reading. Okay. Okay. Set your data. This one is in gate mode. Follow everybody? Okay. Yeah. Okay. Okay. Before we start, let us do some correction and I'll give it to you. Okay. So page 2, procedure 4, cross 50 to 60 grams to 80. Okay. And page 3. Okay, analysis number 2. Okay, draw a second graph showing average acceleration as a function of the glider with MA being held constant. That M should be lowercase m. Follow? Be consistent with the data table. Okay? And page 4. Okay? Keep 4 horizontal entry. Keep a gap. I'll give you this one exactly, and then another 4 entry. If you did not get it, you'll receive it and you'll see what I'm talking about. Okay? And then I'll talk about part B when you are ready to do the part B. Okay, let's finish part A. Okay, here we go. We are ready. So here, okay, let it go. Yeah, yeah. Okay, okay. Yes, everybody, look. So let it go. And then if you look at, and one more thing I need to teach you guys. Okay. So when the glider goes there, Q1, it recorded. Okay. Now, when it crosses this one, there is another time. How do you get that? Okay. Just to show you, there is a button here called read. Please pay attention. Let's say for here it says 0.235. Okay. Okay. So this reading minus that 0.35 is the time, okay, T2. T1 is displayed. In order to retrieve T2, I have to push this switch to the read position. Then you read the total accumulated time, T1 plus T2. You already know T1. So T1 plus T2 minus T1 is the time T2. Follow? Okay? So that's the way it will proceed. Okay? And let's do the second one. Now I'm going to take 10 from here and put it here. So in your table, the first reading was 265 grams is M. MA falling mass was 55. Now the sliding mass is 245. Okay, and falling mass is 75 grams. Okay, so this way we'll continue. Okay, here we go. Okay, so then again we'll change. We'll take another 10 from here. Okay. So now this is 225. Okay, and this is 0.095. Okay. 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 So now we'll take another 25, okay, and put it to the falling mass. Okay. These are all 20 grams. But if I say 10, my mistake, okay, 20 grams. We change by 20 grams. Okay, ready? Here we go. Okay. Now the last one, take it out. This is now 205. Okay? And the falling mass is 115 grams. Here we go. Okay, ready? Here we go. Okay. So this part is done. Okay. Now you white out two, entries. Okay. Now what we are going to do? This, it will be 205. Follow everybody. Which is this 205, right? And then falling mass will be constant, and I kept it 115. So you have 50, another 50, 100, and 105, 115. Okay, so here you go. So this will be constant. Okay, we'll be changing. This okay, okay, and yeah. So we're not going to put anything here. Okay, okay, this is 115. If you look, I remember. So again, we'll do. Remember, we did time from here. We are just not telling you. Okay, here you go. Ready? Okay. So how much was 205, right? We are not changing anything. Now that will be 245 now. Okay. So let me have 100, 50, 50, 100, 45. Here we go. Okay. Okay. Here we go. Hold this thing. Okay. Ready? Yeah. Ready? So now you have 245 falling mass, 115 is the sliding mass. Here you go. Ready? This is very fast. Okay. Okay.
Should I hold this thing on the back side so that this doesn't fall down? Or is it normal then?
Normal. Yeah, yeah. So let's straighten it. Okay. So now this will be 45. 405. Okay. I'm going to use 405. 4 means be consistent with our, 405. So I need 350, 350, 54, 405. Right? Yeah. Okay, here we go. Just the whole. Make it go in. No. Oh, okay. Here you go. I'll stop this guy. Okay.
Okay.
It will be very fast. Okay, ready? Oh, good. Okay. And then, okay. Then 445. Okay. So, what is the 150, 250, 350, 350, and then I need 445, right? 350. No, I cannot put 400, so what is 50? And 445. So, there is no 100. Okay, here. I'm sorry. 150, 250, 350, okay, 350, 370, 390, 390, 410, 430, 440, and what is that 5 gram one? The small
This is a one.
5 gram. There is a 5 gram. Oh, maybe in the floor too.
Oh. No.
5 gram. Yes. No. Yeah. Yes. Okay. So this is 445. Here we go. Let's do that. Here we go. Yes. Yes. Okay. Ready? Let it go a little bit. Okay. Okay. Ready? Okay. Oh. uh, ready? Okay. Okay. Shall I? Shall I?
Yeah.
Okay. Let it go. There we go. Okay. So we are done. Part A. Part A. Okay. It will take us 5 minutes to set up part B. Then we'll come back in 5 minutes. Thank you. Okay. Part B. Right. And few corrections, and then we'll start the experiment. Okay. Here we go. If you look at your page 7, your data table, 5B1. There are two entries, A and A average for the acceleration. Just eliminate one of the column, okay? Because it's the same thing, okay? That is the correction. And if you look at the setup now, a wooden block here to raise it. Now a component of gravitational force, okay? G sine theta, okay? And this angle I'll give you is 2.2 degree, something like that, okay? So I'll provide that number, okay? So now, if you let it go, that component of the gravitational force, okay, will accelerate it. Hello? So here, on it, the record time is T1, okay, time, if you go to the data table, time T1, T2, and T3, and then take the average of it, okay? For here, I'm just showing you how to do the experiment, and I'll provide you data. So if you just do the experiment as if you are here at the lab, and then you'll take for each run, okay? You'll take the time measurement, and then by knowing the time and knowing the distance, 0.025 meter, you get the velocity, okay? So the velocity will be higher when it crosses the second photogray. Follow? So difference between these two velocity and the time of travel will give you the acceleration. And this acceleration will not be g, it will be less than g. Follow? Because it is not straight falling down. Okay? So here, let's do the experiment and see how good the results will be. Okay? So table 5A1 I'm looking for, and okay, here we go. Okay. So you measure, you change the mass, okay? This is 205, then put 245, okay? And then put 285, then put 305, then 505. And every time you just let it go, okay? And measure T1, T2. Obviously T2 time will be shorter because it is faster here, okay? So if you look at the table, T1, T2, then this 0.025 divided by T1 is V1, and 0.025 divided by T2 is your V2. Follow? And V2 minus V1 divided by the time 0.025 will give you the acceleration. Follow? And that is your experiment. You finish the data table and you can calculate F of G, force of gravity. If you multiply mass, which you know, you measure. And now if you look at your table, if you look at figure, there are parameters uppercase D, lowercase d, which clearly show you in page 5 in the data table, right? H, thickness of the wooden block, D, distance of travel for the air track, and uppercase D is the separation between the two photographs. Okay, so basically this is the experiment for you guys, and by looking at the data table, I am actually providing you, okay, all the calculations also for V1 and V2. Okay, so then you take a graph paper and plot, the mass in kilogram in the x-axis and the gravitational force on the y-axis. Okay, and if you take the slope will be, acceleration due to gravity. Okay, and that is our experiment in part B. Thank you. Okay, I'll explain more in the class. Okay, thank you guys. Bye bye.